Good at remembering to record. Even at my advanced age, um, maybe it's the fact that I've gotten back to playing piano that my memory's getting a little better. Not a lot, but a little better. Um, for sure, muscle memory. Okay, anyway, I'm sorry. Okay, let's see. Let's start on reactions here. Okay, so this part of the reactions for aldehydes and ketones is kind of a review of Unit 1, where we take oxidation of alcohols to either aldehydes or ketones, depending on whether it's primary or secondary. Um, and the most important thing to remember about this set of reactions is it is reversible. So to create an alcohol, you can reduce a ketone, you can reduce an aldehyde, and they end up producing either a secondary or a primary alcohol. And when we're talking about oxidation, um, the aldehydes are very unstable in general. That's why when you drink, your liver detoxifies ethanol by converting it to the aldehyde. And that aldehyde is then further detoxified out of your liver with something called aldehyde dehydrogenase. And depending on how much of that enzyme you have in your liver, the quicker you will detoxify the ethanol. So if you don't have much of that enzyme in your liver, that aldehyde is going to stick around and cause cirrhosis of the liver. Um, so it's a genetic thing. And when I say genetic, I'm talking about not only your parents, but your culture. Certain cultures have bred out all the people over the last couple millennia that don't do alcohol very well. So they're basically through selective, you know, um, concentrations, have developed a series of a population that has a high amount of aldehyde dehydrogenase in their system. That's just a genetic thing. Nothing to do with anything else. It's a genetic thing. Those individuals can take a lot of alcohol because it's immediately detoxified in the liver. Other cultures don't have as much over the millennia because they haven't been drinking for that long. So they haven't been able to weed out the people that have low amounts of aldehyde dehydrogenase enzyme. Anyway, it's kind of an interesting perspective when you look at the cultures and their propensities towards certain illnesses, certain things. It's really interesting to study that. It's more of a sociological study than a biochemical study. Anyway, so aldehydes are easily oxidized, ketones are not. And it's mainly because of that hydrogen here. The hydrogen that's attached to the carbonyl group. There is no hydrogen attached to carbonyl group down here for the ketone. Hence, it can't oxidize. Okay, so we can take advantage of that difference in ability to be oxidized from a qualitative standpoint, determining whether we have a ketone present or an aldehyde, because we put an oxidizing agent on it, And if there's no change in the oxidizing agent, for example, this is potassium dichromate, it's an orange color to start with. So if it changes color, that means that it has reacted. So if it changes color, that means it's oxidized an aldehyde, hence the color over here. So this is an aldehyde in this test tube here on the right. In the middle is a ketone. When we put this in each one, notice the one in the middle has no change. It's still orange. But the one on the right, there's definitely a color change. Now that color change depends on the oxidizing agent you use. Some change colors, some don't. I like to use the ones that change color because then you can use them as a qualitative test for a certain kind of functional group. Okay, and then there are two main tests that's used to distinguish between the two. Tollens and Benedict's. Tollens uses silver cation, and Benedict's uses copper 2. Copper 2 is a +2. So basically you need to know these reactions because these are the ones we use with carbohydrates as well. Okay, so as you know from Monday's lecture, that hemiacetals open up to aldehydes. So when they do open up to aldehydes, the Benedict solution or the Tollens solution can then react with that aldehyde and oxidize it. And hence the oxidizing agent becomes reduced. So copper 2 is reduced to copper 1. The aldehyde is reduced or oxidized to the acid salt. Now this is done in a basic environment. So there's no H here. COOH is just COO with no H because we're in a basic environment. So if we were looking at butanol, and we threw in a basic environment, Benedict solution, copper +2, and what happens is the aldehyde is immediately oxidized to the acid salt, which is this. It's got a negative charge. And then the copper 2 is oxidized to copper 1. And what happens is two of them react with oxygen and turn this orange color. Now the orange color can be orange, it can be kind of a orange green, orange blue, but it happens really fast. I mean, I'm talking about like 3 or 4 seconds. It goes really fast. And you put it in an you put it in a boiling water bath. So it's very hot. So reaction goes very fast. Tollens is trickier. I think it's a cooler reaction because you end up with a test tube with a mirror on the bottom. But it takes longer, and sometimes the silver will tarnish and get all dark and not silvery, mirror-like. That's why most people use the Benedicts, because it's fast, it's very reliable. It's not persnickety like the Tollens is. So between the two, make sure you know Benedicts. This will be on the test for sure. Okay, let's go on now here. Now I mentioned that the oxidation process is a two-way street. There's oxidation, and we can also reduce it. Reduction is the opposite of oxidation, as you know. Oxidation is the loss of hydrogens or the loss of electrons. Reduction is the gain of hydrogens or the gain of electrons. Now, this happens a lot biochemically in our body through enzymes. Okay, so aldehydes are reduced to primary alcohols. ketones are reduced to secondary alcohols. If you oxidize a primary alcohol, you end up getting an aldehyde. If you oxidize a secondary alcohol, you end up getting a ketone. During the reduction process, we usually need a catalyst, a metal catalyst, and frequently we use platinum. Sometimes we can use chromium, sometimes we can use nickel, but most of the time it's platinum, which is PT. Okay, the backbone remains the same. So 3-carbon backbone, 3-carbon backbone, 3-carbon backbone, 3-carbon backbone. Now, this anomeric carbon isn't mentioned much in aldehyde ketone chemistry, but the anomeric carbon is extremely important in carbohydrate chemistry. So I always make a point of pointing out where the anomeric carbon is. It's the carbon that's attached, not attached, but associated with the carbonyl group. So once we go into a reaction that involves an aldehyde and an alcohol, that's when we start getting involved with the anomeric carbon, because the anomeric carbon remains the anomeric carbon throughout the process. And that's where all the attachment and changes occur, is on the anomeric carbon. Now, in carbohydrates, if you remember from Monday, that's always carbon 1 for 6-carbon monosaccharides, like glucose, galactose. For 5-membered monosaccharide like fructose, is carbon number 2. Okay. All right. So we have an aldehyde with an alcohol. We end up with a hemiacetal. Hemiacetal with an alcohol gives us a full acetal. Now, the alcohols, importantly, don't have to be the same alcohol. For example, if we were to change this, this is R1, this is R1, but if we made this R or double prime, we would have this situation where this group up here is different than this group down here, like in carbohydrates. Hemiacetal, in general, are not very stable. So they usually immediately grab another alcohol to become a full-blown acetal, which are more stable, except for carbohydrates. Cyclic hemiacetals are quite stable because all the glucoses and galactoses and all that stuff, those are all hemiacetals, and they are fine being a hemiacetal. You've also got secondary and primary backbones. So it's important to, the primary backbone is the one attached to the carbonyl. The secondary backbones are attached to the alcohols that are connecting to the anomeric carbon. And then we can always apply the OCO tests, like over here. And let's do the OCO test here. So OCO is yes, because that is right here. OCO. And we have hydrogen there. We do our tricky mark here. And then we have OH, and we do. So OH means it's a hemi. H means it's an acetal, either hemi or full. So because we have both of these checked, that means it's a hemiacetal. If we do OCO over here on the right, we've got no OH, that means it's not a hemi, but we do have an H, that means it's an acetal. Over here in the far left, we've got OCO is not there. So it's neither an acetal or a ketal. And you need to get used to doing these little tests. Now, if we go to Canvas, Files, Unit 2, Worksheets, I do have some worksheets for you, and those will allow you to practice naming reactions, and I also give the answers as well. And of course, there's always the flow chart. Have any of you started working on the worksheets yet? Now, the problem is the worksheets don't do carbs. I need to make up some new ones involving carbohydrates, because that is important as well. I may just do that tomorrow, since I have off tomorrow. And I'm not doing bridge tomorrow, so I'll have a lot of free time tomorrow. Yes, I think that's what I'll do. I'm going to make myself a note. Okay, let's get back to okay. This is just more. This is using ketones instead of aldehydes. So we always have just try to form a habit of identifying the anomeric carbon. That'll help you with these acetals and ketals, because all the action takes place at anomeric carbon. Now, this is kind of a harbinger of what's coming in regards to the carb unit. And that is if we have a molecule that's long enough that contains on one end an alcohol, the other end is an aldehyde or ketone, we can form a intra reaction here involving the same molecule. But it's got to be long enough. It's got to be at least 5 carbons long. Now, most carbohydrates are 6, except for the furanose versions, which are like fructose, for example. It's got branches off of here for fructose. There's another carbon up there. So it's got to be at least 5 carbons long with an OH group on the end. Or if it's longer than, because we need to form a stable cyclic, heterocyclic. If it's more than 6, it's unstable. If it's less than 6, it's a little less stable. Although 5 with fructose is pretty stable. But that's about it. So it's got to be long enough so it can circle its way back around. Okay. So we can form the acetal or ketal, but we can also um, reverse the reaction. So these are all two-way. They're all two-way. Now notice if we start, let's see, let's go back up. If we start with an acetal, we're going to go back when we reverse this reaction. We're going to go back to the aldehyde and two alcohols. There's an intermediate step there, which is the hemiacetal. So let me show you what I mean by that. Okay, if we start with so you've got okay, so this is a ketal, and we have OCOH, no OH. What happened? What's going on? Where did that go? Hmm. No, right here. Okay. Okay, so it's a ketal because we have OCO is yes, H is no, and OH is no. So we have a full-blown ketal. Okay, so in a water environment with some acid, what's going to happen is we're going to have an intermediate step, which is going to free up one of the alcohols. So we still have our backbone. And then it's going to continue on. Now let's analyze this intermediate step real fast to figure out what it is. So we've got OCO, we've got OH, and we have no H. So this is going to be a hemi ketal. And if we continue this on, and say I'm going to get rid of this other alcohol. And again, these can be different alcohols. They don't have to be the same alcohol. So we're going to free up now and get back to the original backbone. Oops. Original backbone and the anomeric carbon. Let's do the anomeric carbon with a dot. And it's going to give us the alcohol. And this is going to be, if we analyze this guy, so OCO is not there. There's no OCO. So it's not an aldehyde, excuse me, it's not an acetal or a ketone. Okay, so the thing that this slide didn't show was the intermediate step. Going to the hemi version, whether it's a hemiketal or hemiacetal. Okay, so this is the additional part that's added on from Unit 1. And this is the part that gets us into the carbohydrate subunit. And then the important aldehydes and ketones. The simplest one is formaldehyde. Formaldehyde is used a lot in science. It's used a lot in industry in terms of glues and stuff. For example, if you buy plywood or OSB, you'll see a California warning on there that says there's things that cause cancer, which is the formaldehyde they use in the glue. So if you move into a brand new house, houses nowadays are covered in a particle board-like substance called OSB. I think it's OSB. But it's used on the roof, it's used on the walls, and it's used on the floor. If you have a slab foundation, it's not used on the floor, but the second floor story does have a OSB floor. So you're surrounded by stuff giving off formaldehyde. If you take A&P, which all of you probably are going to end up taking anatomy physiology, a lot of the specimens you're going to be analyzing are cured or preserved in something called formalin. Formalin is just formaldehyde and water mixture. It's all it is. It's not any safer than formaldehyde, but it's also called embalming fluid. And the reason why it's used in specimens is because it preserves the flesh. So if you're breathing this stuff, it's preserving your throat and your lungs and all kinds of stuff, doing the same thing as when we dump formaldehyde into those specimens that you're analyzing. So formaldehyde is not a nice chemical, and we use it a lot in industry, and we use it a lot in the science industry as well in terms of doing specimen embalming and that kind of stuff. Acetone is another, okay, so formaldehyde is the simplest aldehyde. Acetone is the simplest ketone. Ketone is used, I'm sorry, what? Okay, so
My bad. I
acetone,
didn't know I was unmuted.
are we okay?
I said sorry. I didn't know I was unmuted. My bad. Can you hear me?
Okay, no, it's fine. So I thought you had a question. Okay, so acetone is used a lot. Frequently, you come across it in two areas. One is nail polish remover, because it removes lacquer very nicely. If you're a model builder, you have those little bottles of tester paint. One of them is I forgot what it's labeled, but it's basically a remover, I think it's called. But it's acetone and it's just a lacquer thinner, basically. So the problem is if you have um, treated fingernails, they're coated with the color is lacquer. So if you are in an organic lab like ours and you run across acetone, make sure you keep it away from your fingernails. Now, if you're not wearing fingernails that have any nail polish on them, not a big deal. So if you do, you just make sure you wear gloves. It's also used a lot in industry, particularly the fiberglass industry. It's used a lot as a solvent, and it's also not very good for you. Not as bad as formaldehyde, though. mainly because it's formaldehyde's an aldehyde, and aldehydes are more unstable than ketones. Okay, and then biochemically, alcohols, ketones, aldehydes are seen a lot in biochemicals. A lot. Um, the properties of aldehydes and ketones are um, very fragrant. You'll see a lot of them used for flavors. Um, so they're very, very common. Okay, so that's the review on aldehydes and ketones. I guess today's lecture was short. Are there any questions in general? Again, I'll have that extra worksheet um, up tonight or tomorrow, probably tomorrow, being realistic. And it'll be extra practice. And I'll also have an answer key as well. So, all right, any questions about anything? You'll get your test back Wednesday, folks, today, and Monday, folks, on Monday. And Monday, folks, if you want to show up today in lab, if you're on campus, you're more than welcome to drop by and grab your tests. And then I'll put an assignment up. I think I already have it up, actually. But let me check. Yeah, so here's the assignment here. Notice this is 1 point. The reason why it says 1 point, I should have had 0 points there, because what I'm going to do is I'm going to go to your test one and correct it if you submit corrections. Okay, so how are we doing, you guys? Now on next week, I'm going to get into carb review, and then on Wednesday, I think I'm going to go over the worksheets, both the aldehyde ketone one and also the carb one I'm going to be making tomorrow. And then on the following week is going to be the test week. On Monday, for the people that want to take their test on Monday, I'll have it available. And then, or you can wait a Wednesday to take it. It'll be just like last time. We'll have 2 rooms available on Wednesday, and we're just split up. The only concern I have is that some of the questions that some of you answered were very AI-like. They were very Google search-like, which concerns me because you shouldn't be having your phone available. So anyway, so we're going to have to deal with that and in future tests. Okay, so how are we doing, you guys? So
I
if
think,
you haven't,
oh,
go
yeah, I
ahead.
was just saying good so far. I think the worksheets will help a lot because if there's any questions I have that I don't really know how to ask, maybe doing the worksheets will bring those up.
Yeah, yeah. I think the worksheets are really handy. Um, in my spirit, I'm not teaching this next semester though. I'm teaching it in the fall. Um, but I really think they're valuable. Teaching 300 next semester, which is similar to what I'm teaching up in Sierra. So it'll be very easy in terms of teaching them because it was the same class. Um, labs will be different, but the lecture will be exactly the same actually. So, okay, so anyway, if there are any other questions, I'm going to go ahead and end this. I think I can get to lab earlier than 3. Monday I was here at 2:30 and some people started. Now this is a really good lab. You're going to use some very sophisticated glassware. Um, and no one broke any, which is really nice because it's almost $200 a set. And so anyway, it goes. So don't forget, we need one orange per person. You're going to be working groups of four. So if one person in the group brings four, that's fine. I just need to end up with four oranges per group. Now on Monday, Kaylee brought in green oranges from her tree. And we actually tasted some of them. They actually were kind of interesting. They tasted a lot like kind of a sweet lemon. It was kind of interesting. I've never had and when I lived in Florida, we had grapefruit and orange trees in our backyard all over the place. I never tried them when they were green. Of course, I was a teenager then. So anyway, bottom line is we need four oranges per group. And we're going to be working in groups of four-ish, possibly five, but groups of four worked out well. Okay. Anything else?
Wait, so you said you'll be in lab earlier today?
Yeah.
You said around 2:30?
At least by 2:30 or maybe even earlier. I just gotta basically put on my shoes and
Yes.
I just gotta put on my shoes and walk the dogs.
Yeah.
Okay. You think you could like send out an email when you get to lab if you
Coming. I just don't know what I'm supposed to charge you for the cow.
if you do show up to lab early, I would like to come a little bit earlier.
Today just 62.
Yeah, I'll send it out right now.
Yes.
Okay, thank you.
I got 20 of Roma and 20 of this one.
We're gonna do a regular box press because this comes out to $60.
Whatever.
So we're gonna do 35.
That's fair for you?
Yeah.
Whatever. Thank you.
And you can do this, Andre. You don't need me. No, I don't know what to do with the tomatoes. Yeah, just charge whatever you want. This is my daughter.
All right. Well, I'll see you in lab, Professor.
Nice to meet you.
I'll do the rest.
Yeah, I'm gonna send out
I
an
forgot
email
you're
right
in
now.
class. Oh. Yeah, I forgot she was in class until I heard the person talking.
College?
Yeah.
Okay, so I'm
Yeah.
gonna sign off.
Yeah,
Any other
Professor,
questions? Yeah.
can I actually talk to you on one-on-one, like a little bit?
Yeah, how do you want to do that?
Like, like right now? Is that fine?
Yeah, that's fine. Do you mind if other people are online?
Yeah, I'm waiting.
Okay. You're gonna wait for everyone to sign off? Is that what you?
Yeah, that's where I'm
Suggested.
at.
Oh, yeah, sure. Hey, everyone. We need to have everyone get off. One more person. Who is that? Salvador.
Well, I don't think. Yeah, it's fine. But what's it called, Professor? Um,
Yeah.
for the test that I missed, did you see my email that I sent you?
Yeah, we had talked about that before you left, right?
Yeah.
Okay, so when do you want to take the test?
Well, I can still take it.
Yeah.
I just didn't know.
Why was it a family trip you had to go on or training or something?
Yeah, it was a funeral. But I was in New York with family until like Wednesday night. I came back Wednesday like at 11 p.m.
Yeah, so you can take it today if you want. Are you ready to take it?
Honestly didn't know if I was able to still take it, so I wasn't really. But
Right, I understand. Well, then why don't you take it Monday then?
Monday will work. And
So
am I still able to turn the dry labs too? I don't know because it is late and everything.
yeah, turn in the dry labs for sure.
All right.
And if you missed a wet lab, turn in a pre-lab so you get credit for that.
Oh,
And then
and then
if you
my
decorate
bad.
your lab coat, you can get 10 points, so that'll cover a wet lab.
Okay. Oh, for the wet lab that was last week. Did we just fill out everything in the comp book?
Yes.
And like we
All
just
wet
send that.
labs.
Is there like I don't know, like, because I don't see any due dates. Where do I send it in? Or like, does it have a due date on it?
Yes, you click on assignments
Hmm.
and go down and look up the alcohol lab. When you click on that, it'll prompt you for a file. And that's the PDF of your scanned dry labs or wet labs.
Okay.
So everything is on Canvas and you go through assignments, and that's how you are able to submit stuff through assignments.
Okay. I just whole files things like it's just not really like I don't know like organized. Like I just don't know what to do and what not to do. So I was kind of confused on that. But
Well, you just do the write up for the wet lab.
uh-huh.
I know you missed
Well,
it,
I
but
did the pre-lab yesterday. I mean, I did the pre-lab for the last week labs, but I was ready to come in and everything. It just that's when you couldn't come in, and which was like fine, obviously. But oh well, not it wasn't fine that you couldn't come in, but like I'm saying, like I was ready for the last lab, but I just don't know what to do with the data you had sent.
okay, the data I sent, you're going to use that like you actually took the lab. So go
And
to
we
the
don't.
data tables in the data that I sent you and fill in your data tables with that. And then you're going to answer the post-lab questions and a
Mhm.
conclusion. And then you're going to upload that, scan it and upload it.
Do we have to write anything at the actual lab, like manual?
Yeah, you're going to do the lab, only I'm going to give you the data like you did the lab.
Okay,
Does that make sense?
yeah, that makes sense.
Okay.
And then also, I was. Do you have any extra lab coats? I came to the Canvas store to come buy one, but they said they sold out, and I didn't get any from Amazon either. And yeah,
Um,
I came in thinking that they would have it today,
well, you can get for sure on Amazon.
but yeah, Amazon for sure. Yeah, I just I was able to get it like day of the day lab like from the actual store, but they were sold.
Yeah, yeah. Amazon's probably going to be cheaper anyway. So
Do we need a lab coat? We need a lab coat today too, right?
yes, do you have your goggles?
Yeah, I have my goggles.
Okay, you can rent the lab coats from the stock room.
Okay.
So that bring $2 in cash, and they have change too.
Oh, in cash, they don't take anything like electronically? I don't have. Well, actually, never mind. I can go get cash real quick.
No, they don't do anything electronic. And they used to do Venmo, but they don't do that anymore either. There was some legal thing why they couldn't do it.
Okay. Well, I can get cash real quick, then that would be fine. But yeah, that was really all I wanted to talk about. But I
Okay,
appreciate you talking to me.
sure, sure. So who in your family passed?
My auntie,
Were you close?
we weren't too close, but like my mom, well, obviously that's her sister, so like we had spent time over there with the family over there and everything. and the funeral was on like on Tuesday. So like I don't know, it just I wasn't really close with her, but my family definitely like it was impacted. Well, including me too. I wouldn't say I'm not like, but we all like kind of grieve differently and everything. But like,
Yeah. Yeah. Well, I've gone through a lot of, because of my age, I've gone through a lot of people passing in my life. And
mm,
the most important thing to do is to get closure, emotional and psychological closure. You know,
uh,
because if you let that hang on, it'll haunt you. When my dad passed, I was how old was I? I was 20, trying to remember now. I was in graduate school, so I was 20, 27. And I didn't get closure with him for 2 years. And I finally broke down and started crying. It was awful. When my mom passed, I didn't let that happen. I got emotional closure, within like a month. And it was so much better. My life was much cleaner. So all I'm saying is um try to, come to terms with the fact that your aunt is no longer in this world. She's in a better place
mhm.
and feel good about it.
I
Um,
appreciate that.
you'll miss her for sure, but just remember that, you know, are you very religious?
Um, Somewhat religious, yeah. I like Christian with God, all that. Yeah.
Well, just think about things like what Jesus said about passing.
Okay. But thank you for talking with me though. I appreciate it a lot.
Yeah. And again, I come to terms with your aunt passing, and because it's not a bad thing for her. Was she sick or was it sudden?
Um, it was pretty sudden, I can't lie. It was a car accident.
Yeah.
So like, yeah, it was like I think she was going like a good 80, 90, maybe like around there. And I think like she lost control or something.
Oh, she was driving.
Yeah. And she like wrapped around a tree.
Hmm. Well, hopefully it was quick.
Yeah, hopefully she didn't really endure too much pain.
Yeah, that's what I mean. Yeah.
So
Okay. Well, it sounded like she lived a good life, though. Isn't like uh, she lived
yeah,
in her 80s and 90s.
yeah, I would say she did like her and my mom pretty good, pretty close, grew up pretty well, everything. I would like to think that she had a great life. Yeah. Well, I don't really have anything like any questions or anything else to talk about. I appreciate you, speaking one on one with me. Appreciate like
Sure.
you still letting me take the test that I missed because I know like a lot of professors don't really do that. And yeah, I appreciate that a lot.
Sure. Sure.
And I'll see you at lab, okay?
Okay. All right. Take care now.
All right, you too.